So this is episode 11 of Prologue is Amazing. Today I was looking at Log Talk and Mercury Prologue. So the way to think about it is Log Talk is kind of like is Prologue with object orientation, and it gives you things like interfaces and objects and inheritance, class instantiation. So it's like for if you want to do Prologue, but you want the features of object orientation. And Mercury Prologue is like Prologue with Haskell features. So it has a type system, and you know, it basically is trying to add the features of Haskell into Prologue. It does have stuff that Haskell doesn't have, but Haskell has stuff that it doesn't have as well. So I can't remember exactly what, but it's a interesting system. The only thing with Mercury Prologue is such a niche language. There's not that much documentation for it, but if you're trying to use it, you must know what you're doing. It is using the print system I read, which is I think they use it in Google Chrome, where given any HTML and its CSS, it outputs a PDF document. So I think that's how Google Chrome outputs PDF. Mercury Prologue is like 20 or 30 times faster than the normal Prologue because it's a compiled language, and and it was saying it's 5 times faster than Aquarius Prologue, which was a system from the 80s or early 90s, which, the guy who wrote Mozart Oz and then Alice ML, he did that. And the way Aquarius Prologue worked to make Prologue much faster was it did a global analysis of the Prologue code and then output efficient code. But the Mercury Prologue people were saying it does an approximation because of the time required to do the global analysis. Mercury Prologue, it kind of like it has it allows you to declare the types like in Haskell, but it also has type inference, so you don't have to declare all of them. And there's a determined modes system where it's like Prologue can run every predicates in multiple ways, and the modes you specify modes so that some are in, some are out, and you can have different modes for every, and you explicitly specify it. And so yeah, that's the thing. It seems like once you get used to it all, it's probably a good language, and it's fast. It's a statically compiled language and catches lots of bugs and things. All those features. Logtalk is like programming in the large. Most software code in the world is done using objects and stuff. And also, I got from the OCaml people that modularity should be the main feature of coding. Except, Logtalk, like Prologue doesn't have the static typing that OCaml does, but Logtalk does have, a lot of the OCaml features of, interfaces, and it has something like parametric poly. I don't know, like there's ways you can. Yeah, I'm not sure. I think it might be just basically the features Java has, or Java class system. Although I think the Java class system is single hierarchy, where the Logtalks one is multiple hierarchy, and then the Java doesn't have prototypes, where Logtalk has prototypes, or you could just instantiate an object. So I'm not sure whether Logtalk's modules is as good as the OCamls. Obviously, in one way, it can't be because Logtalk doesn't have static typing. So, yeah, and Mercury doesn't. Mercury has type classes, but it doesn't have, the OCaml system of modules. So, yeah, it's a confusing thing. Maybe there are other Prologs which also have static typing. Probably not. And, well, maybe there is. I need to look into it, but they won't be fast static typing, like properly compiled like the Mercury one does. But maybe they have Prologs that try to incorporate all the features of the OCaml module system. Now, there is an argument to be made, but why do Prolog then? Why don't you just switch to OCaml if you want the full modularity, and then use some kind of constraint programming inside OCaml to do the Prolog-esque features? So yeah, that's a possibility. Maybe ditch OCaml, ditch Prolog and go to OCaml. I think that's what the Aquarius Prolog and the later Moza Oz guy ended up doing, which was, just do OCaml kind of thing, or, ML meta language, and use this constraint programming library. Yeah, and another thing to think is, well, whether all of this is even necessary. Like, why not stick with Prolog? And is object-oriented actually good? Like, maybe Prolog is the right way. You don't need object-oriented programming. But maybe you do for large-scale programming. And then the second is, yeah, so, like, maybe, with Prolog you can do large-scale software engineering. And maybe, in some way I thought it's like once I heard in a podcast from one of the Prolog people, it's like you use Prolog itself to kind of guide you through the software development process. Like, one way is you keep extending Prolog using like meter interpreters to do what you want. So you can try to stay in fact space, let's say, or rule, and then, or I don't know, like you even rule space, but you use meta interpretation to increase the functionality. But another way is like, all your Prolog code is available, and you could do something like I thought, where you're like, what predicates am I not using as Prolog to tell me them? So it's like a mental check, right? Like, oh, you define these predicates, why aren't you using them? Or these, maybe, querying you, like, maybe this predicate is useful to you, or do combinations of, like, well, is this, right? Like, something to jog your memory about the existence of predicates you've already defined. And so that maybe you're like, well, I need to use this, or right, or maybe you enter a query like, I'm trying to do this, and then Prolog will output, well, maybe these predicates might be useful to you, something of that nature. So kind of like a fuzzy system for letting you know the things. Because I was thinking, even in something like a powerful module system like OCaml, like, you still have to know the existence of the modules. Now, the thing is, it's basically kind of like the camel, or you know, the static typing of OCaml and Haskell is something to do with category theory, and maybe you can, maybe define enough types of modules of OCaml and combine them in ways that the space of possibility is reduced so that you can handle the complexity. And maybe the complexity of Prolog is larger because it's kind of like a flat hierarchy of predicates, right? Like there's no way to be combinatory in that way. Like an OCaml module could be a combination of smaller submodules, and those submodules are kind of, you know, things that are universal or quite common, right? Like a list and the operations on a list, take stuff off or put stuff on or sort, or put stuff at the end, put stuff at the beginning, etc. And then these aspects are kind of universal, and you can import that module for another module, like something like that, like this. Whereas in Prolog, the flat hierarchy of predicates, how do you go about, creating further abstractions out of them? And I was thinking this because, like, category theory is how mathematicians are kind of like trying to make maths easier, or, abstracting out from all of mathematics. Like there's a project to rewrite mathematics in terms of category theory, or something like that, give category theory definitions to all the different subfields of math so they can be more easily understood by different field practitioners or different areas of maths. Whereas maybe predicate logic is like something like set theory, and it's more difficult to do, or something like that. I don't understand math, so that's what I'm assuming is what they're trying to mean by that.